Welcome to this explainer detailing the structural refinement of the machine economy stack. It's really been our canonical framework for making sense of the emerging machine economy. But today, we're diving into how months of intense, real-world application have actually pushed this model from just a solid theory into a battle-tested institutional framework. We're going to walk through a crucial structural refinement that makes it way more powerful than it was before. Here's our roadmap for today. We'll be covering the canonical framework, structural friction in practice, the dependency sequence refined, one unified architecture, and finally, tracking economic gravity. Section 1. The canonical framework. To start off, we really need to ground ourselves in the stack's baseline purpose. Remember, this is a dependency framework. It's not just some static sector map. Since we first published it back in February 2026, we've used it constantly across AI, robotics, machine commerce, and infrastructure analysis. And you know what? It has repeatedly proven its worth. Why? Because it pinpoints the actual sequence of dependencies the machine economic activity needs to happen. It nailed the fact that value naturally accrues toward infrastructural bottlenecks, the layers where scarcity and control are highest, rather than just the flashy intelligence layer. It also hammered home a super important reality check. Intelligence alone doesn't create economic activity. For reasoning to matter, it has to be powered, executed, and settled in the real world. And absolutely none of those core tenets are changing today. Section 2. Structural friction in practice. So here's the thing. When you subject any framework to months of intense real-world testing, you're going to find its friction points. It's totally inevitable. And that brings us to a core philosophy we hold. A framework should explain reality, not force reality to fit the framework, right? If the map doesn't match the territory, well, you redraw the map. And a minor correction became absolutely necessary because of exactly where the machine economy has been growing the fastest. So, what was the anomaly that forced this rethink? It was autonomous software agents. You see, the original stack placed embodiment below logic and reasoning. And honestly, that worked pretty well for industrial automation, where a machine's physical interface with the world is the whole point. But think about a modern software agent today. These things can reason, plan, negotiate, and generate massive economic value without ever having a physical form. It's like they can take our jobs without even needing a body to sit in the chair. It requires deep computation and reasoning, but literally zero physical embodiment. By initially placing embodiment below logic, we were kind of forcing a really awkward, disjointed analysis for these bodiless software systems. Section 3. The dependency sequence refined. To resolve this ambiguity, we went in and made a highly precise structural refinement. If you look at the shift from version 1.0 to 2.0 here, the adjustment is super clear. Logic, reasoning, and interpretation was moved ahead of embodiment, sensing, and actuation. Basically, we just swapped layer 3 and layer 4. And by doing this, the revised stack finally separates cognition from physical execution, ordering them exactly how they actually run in the real world. Think about it. A system perceives, it interprets, it decides, and then it acts. Reasoning simply has to precede execution. The dependency sequence now reads cleanly from the base upward. First, materials, then energy, then reasoning, followed by physical execution, and finally, settlement. The core logic of the whole framework is completely intact, and the actual contents of each layer haven't changed one bit. But this simple reordering strengthens those layer boundaries immensely. Section 4. One unified architecture. Now, the primary achievement of this revision is a total game changer for allocators and analysts. We now have one single unified architecture that explains both the digital and the physical machine economy. Let's look at the two archetypes that matter most right now. Take a pure software agent. It draws on energy and compute at layer 2, moves up to logic and reasoning at layer 3, and then skips right to identity and settlement at layer 5 to act in the world. It completely bypasses the physical embodiment layer. On the flip side, a fully embodied humanoid robot traverses layers 1 through 5 in full, resting on physical inputs, running on compute, reasoning, actuating through its physical body, and settling its actions. Before this tweak, you essentially had to use different models to analyze these two. Now, whether it's a bodiless agent or a fully embodied humanoid robot, you're engaging the exact same framework, just at different depths. Section 5. Tracking economic gravity. Now, for institutional allocators, I want to be super clear. Freezing the framework's order does not mean freezing the investment analysis. The map is fixed, but the destination is definitely moving. Crucially, this refinement doesn't invalidate any prior MMM analysis. The stack was built to identify constraints, and economic gravity naturally migrates over time. As of right now, our core investment view is completely unchanged. The most significant constraints, and therefore the heaviest economic gravity, are still firmly concentrated in those foundational lower layers. We're talking power, compute infrastructure, and physical industrial throughput. So, taking a look at the fully specified, revised machine economy stack, I want to draw your attention to layer 5 at the very top: identity, settlement, and liability. Now, this was always there, but integrating it explicitly like this completely finishes the story. Why? Because while the lower layers describe how machines operate technologically, layer 5 describes how society actually permits them to participate institutionally. A machine can be incredibly smart, but intelligence alone doesn't magically create an economic actor. It needs institutional legitimacy, authority, governance, and liability to become a real participating agent in our economy. The machine economy stack is now this incredibly stable, anchored substrate, but the environment around it, it is deeply dynamic. Which leaves us with this final thought. We know the constraints today are mostly in energy and materials, but as physical autonomy scales up, and as these software agents begin negotiating and transacting on their own authority on a massive scale, when exactly will the dominant bottlenecks shift from the foundational infrastructure we see today over to the institutional and settlement infrastructure of tomorrow? That is the exact migration we are watching. And thanks to this refined framework, we have the perfect lens to track it.